We're in section 2.3, rotations today, and you need to have a basic idea of what rotations are. So just on your notes, I want you to draw an X and Y axis just on your notes. You don't have to do it on graph paper. You don't have to fully number it. I just need you to roughly plot a point at a value of 5 on each axis. So when you go up, it would be positive 5. When you go right on the x-axis, it would be 5 again. So just try to plot a point that's evenly spaced around the point of origin. Okay, so a point of origin is 0, 0. That's our reference point. Okay, so origin, the point of origin, 0, 0, is usually going to be our reference point for rotations. All right, so we have our initial point at a y value of 5. All right, do you guys have that point plotted on your notes? Okay, you have an initial point plotted at 5. Now we need to understand just the basics, the basic rotations 101, okay? And this is basically how it works. We start at a value, and this can be any value, but I feel like if we start right on the y-axis, it's easier to see how the point rotates. Okay, is everybody familiar with clockwise and counterclockwise? So when we're looking at a clock, clockwise rotates to the right, and counterclockwise rotates to the left. All right, everybody familiar with that? So we're going to start at a y value of 5, and we're going to rotate this point 90 degrees. When I do that, it drops it down to the x value of 5. It has to be the same distance from your point of origin. All right, and that would be a 90-degree rotation clockwise. All right, do you see what we just did? We rotated that point 90 degrees clockwise. So guess what's going to happen if we go another 90 degrees? How many degrees would that be from your original point? 180. Okay, so a 180-degree turn is the exact opposite value. Do you see that? Do you agree that the opposite of a y value of 5 is negative 5, that they're opposites? All right. Has anybody ever heard the term, like a real life, scenario, they made a 180-degree turnaround, like in their life? Has anybody ever heard that phrase? Okay. So we say that when it's been a complete turnaround. Maybe they were going down a bad path, and now they turn their life around and they're going down the right path. We say it's a 180-degree turn because it's the opposite. It's the complete opposite. All right, well, let's do the math. What do you think is going to happen if we do another 90-degree turn? How many total is that from the origin? So now you can see we have 3/4 of the circle drawn. So how many degrees now from the origin is the x value of negative 5? It's 270. Okay, and then of course completing the circle is the full 360, but we don't need to write that part because the only 3 rotations we're doing are 90, 180, and 270. Those are the 3 rotations. All right, you're never going to say, well, what's a 360-degree turn? Well, what happens when you turn 360 degrees? You're right back where you started, okay? There's no rotation happening. All right, so those are the 3 rotations clockwise. So now guess what we're going to do? Counterclockwise, okay? And we're going to erase that 360. So if I go counterclockwise 90 degrees, that's the same thing as 270 degrees. I'm going to try to do this in red. That's the same location. Do you agree? If I start at the same point, if I go clockwise 270, that's the same thing as counterclockwise 90 from the same point. That's really important for you to understand. Do you get that, guys? If you start at the same point, to go clockwise 270 is the same thing as going counterclockwise 90. You end up at the same point. Okay? That's really important that you understand that. All right? Now, if I go another 90 degrees, where do I end up? 180. So 180 is the same whether you go clockwise or counterclockwise. It doesn't matter. All right. Now let's go up. All right. So now I'm 3/4 of the way on the counterclockwise rotation. So now that's going to be how many degrees? 270. All right. So now you've got to get this. 270 counterclockwise is the same thing as 90 clockwise. You see that? 270 counterclockwise is the same thing as 90 clockwise. Again, if you go 3/4 of the way basically backwards, that's the same thing as going 1/4 of the way frontwards or clockwise. All right, so those are the same thing, 90 counterclockwise and 270 clockwise, and then vice versa. All right, you can end up at the same location. All right, now we got our fancy circles drawn. All right, but this is why we set this up. All right, that looks kind of busy when you look at it, kind of like take a step back. You're like, whoa, what did I do there? We're understanding how a point can rotate around the coordinate plane. All right, do you roughly have an idea of what we just did there? Okay, all right, step by step, guys. That's what we've got to do. Just take it a step at a time. Okay, now we're not going to, I want this on the video, and if you draw quickly, you could probably get all these on your notes. You don't necessarily have to have them written on your notes. I need it on the video probably more than anything, okay? But on a quiz or a test, you're going to see a question like this, and it's going to say, here is your original figure, all right? And it's this figure that has arrows on both ends. And point A is your point of origin, okay? That basically means that that is the point in which you're rotating around, okay? So we're rotating around that point. So given that, and I kind of even just use my like hands to kind of try to rotate it like visually. If we were to turn it 90 degrees, this is what it would look like, all right? This is where we really have to use our visual and spatial skills to imagine if I were to actually physically turn this. Can you guys picture that? That I just turned it 90 degrees? And then if I turn it another 90 degrees, this is what it would look like. And if I turn it another 90 degrees, it would look like the last figure. All right, so what it would look like on a quiz is it would say, here's your original figure. What would a rotation clockwise, or I would say 270 degrees clockwise look like? And you would have to pick the third figure. Okay, so you're going to pick the figure that matches with the rotation that it's calling for. Does that make sense? Okay, so it's all about visualizing. Now if I said counterclockwise, all right, so here's a little quiz that we just talked about in the last slide. I know that 90 degree clockwise is how many counterclockwise? 270. Very good. It's 270 because it has to equal 360, right? So I'm just going the opposite direction. So this figure is also 270 degrees counterclockwise. All right, what about this one? If it's 270 degrees clockwise, how many is it counterclockwise? 90. Very good. So it would look like the exact same figure if I said 90 degrees counterclockwise. All right? If you get that, you're really doing well, okay, on this lesson so far. All right? I know that it's a challenge. It's definitely a challenging lesson. Okay? That's why we're spending 2 days on it. All right, this is the last slide that we're going to go over today. You don't have to write the first sentence, but basically what I'm saying here is you can actually use your coordinate rules to find the coordinates of a point after you rotate. So visually, it's very difficult to rotate a figure on the coordinate grid unless you know the points first. If you know the points first, then it's a piece of cake to graph a rotated figure. And here are your rules. If you're going, remember, counterclockwise 90 and clockwise 270 is the same thing. So if you're going those directions, this is how your ordered pairs are going to change between the two. And we'll look more at this tomorrow at the counterclockwise and clockwise ones. We're going to do 180 today, but you need to know all three of these. So just go ahead and write them down. It'll make more sense once we start doing some examples. All right, so you have your rules written down. I'm going to switch slides. Does everybody have your rules written down? Okay, so let's do 180 degrees. All right, 180. So I'm going to give you an ordered pair. -4, -2. Well, 180 degrees says that I take x, y, whatever those are, and I do -x, -y. Here's what that means. It means it's the opposite. Whatever it is in the first one, it's going to be the opposite sign in the rotated image, okay? So if it was -4, now it's +4. If it was -2, now it's +2. That's it. If you're going 180 degrees, it's the opposite sign. All right, so let's do another one. All right, let's do 3, -4. All right, go ahead and here's the fancy word for it and what it's going to say in your homework. Rotate the figure 180 degrees about the origin. That's what it's going to say. Rotate the figure 180 degrees about the origin. What does that mean? That means 180 degrees, you automatically think opposite signs, and then you write your ordered pair. Okay, so go ahead and write the ordered pair. If you're rotating 3, -4, 180 degrees about the origin. All right, so we're not going to be scared off by fancy terminology. We know if it's rotating 180 degrees, what's going to be our ordered pair? Someone raise your hand and tell me. Trey? -3, 4. -3, 4. All right, let's do one more. So we have an ordered pair. I want 100% accuracy on this one. So everybody's going to get this right. I have the ordered pair of -4, 5. I want you to rotate this ordered pair 180 degrees, or this point, about the origin. Rotate it 180 degrees about the origin. All right, go ahead and write down your answer. All right, -4, 5. We're rotating it 180 degrees about the origin. Okay, so if we remember that 180 degrees is opposites, Joshua, what did you put for your new rotated image?
You said rotate 180?
Yeah, 180 degrees, just like we just did the other two. Okay, just think opposites. Okay, so if it's 180 degrees, it's just the opposite. All right, Lily?
4.
Very good. 4, -5. 4, -5. All right, let's do one more. All right, again, we're rotating all of these 180 degrees. I'm trying to get you guys to understand the concept of we're rotating 180 degrees, so what does that mean about my sign? It's opposite. That's it. Both of them. All right, so we're going to go -2, -1. Go ahead and rotate that one 180 degrees. You see how it just becomes kind of automatic? All right, as long as you know it's rotating 180 degrees, it should be very simple. Anthony? 2-1. 2-1. Who got that right? 2-1. Okay, so we're all on the same page. All right, guys, so that's part 1 of rotations. Doesn't seem too bad, and I said it's the hardest one. Okay, it is because of the counterclockwise and the clockwise. Okay, 180 degrees is just opposite though, so we can definitely do that. All right, that's it for part 1 of rotations.